Hey guys, welcome back to another week of robotics. So this week we're going to be using our third sensor. So I want you to take a second and think about what sensors we've used in the past. So up to now, we've used a touch sensor. The touch sensor is going to be the button. So the button is, you can press it, right? And when you press it, the robot or our little robot thing here can sense the touch. The second one is going to be the potentiometer. Now the potentiometer, it can sense using that you can sense the dial position. Remember, the dial can move about half a circle, and then using the analog input on the Arduino, we're able to detect where within that half circle you are, and then with that you can control like brightness of a light or even the position of your the box opening and closing. You can even do like halfway and so forth. Okay, so those are the two sensors that we've used. Now up right now, today we're going to be using which I think is the coolest sensor. It is the ultrasonic sensor. The ultrasonic sensor allows the robot to see how far something is. And if we're able to do that, we're able to actually detect if someone is getting close to the box and then open up automatically without even touching it. So that's the goal here. So before we use and wire the ultrasonic sensor, I want to talk a little bit about how the ultrasonic sensor works. So let's go ahead and do that. I'm going to switch screens here to the whiteboard. Okay, so you should see my whiteboard. Let's talk about the ultrasonic sensor. So let me write that here for us. Ultrasonic. Okay. All right, now to explain the ultrasonic sensor, I'd like to use example from the animal kingdom. You guys may know what I'm trying to draw here. Looks like this. Okay. All right, this is supposed to be a bat. It looks like the head has been detached, but that's okay. So this is a bat. Now, if you may have learned this before, a bat cannot see the same way that we see. The bat doesn't have eyes like us where it can visually see something. It has really, really good ears. So what it does is that it can make sounds and then based on echo, detect how far things are. Okay, so you probably don't hear ultrasonic when you learn about how the bat sees, but you might hear echo, location. Okay, all right, and that is basically the same thing. All right, so how does it work? Well, what happens is that we have this bat here, and let's say we have a wall. So the bat, obviously doesn't want to run into things, and so what's going to happen is that inside the bat, just like us, there's a little brain, right? The brain says within the bat, I want to make sure I don't hit a wall. So what I'm going to do is I'm going to tell my mouth to make a sound, and then a sound starts coming out. And these are the sound waves. It goes, and it hits a wall. And then after it hits the wall, it's going to bounce back. Okay? And it bounces back to the direction of the bat. And then once it gets there, the bat can then tell the distance. Now, what's actually going on there? Well, there's a few things that I want to explain, all right? The thing that the bat is trying to find is this. Here to here, we're going to call this the distance, right? The bat is trying to find out the distance. How far away is this wall? Now, it needs two things in order to do that, okay? The first thing is it needs time. Now, what time? Time for the sound to get from the mouth to there to hit the wall, and then all the way back. Okay, so just to show you again, the arrow, this is the sound out, hits the wall, comes back until it gets to here, and that's where it arrives back. So how long did it take? How long did that going out, hit the wall, come back to this point, how long did that take? So that's time. And the other thing that it needs, okay, is speed. Now when I say speed, are we talking about the speed of that? The speed of the wall? Like, what are we talking about? We're actually talking about the speed of the thing we're measuring, which is the speed of the sound wave, which in our situation is the speed of sound. Okay? So the bat kind of knows this in its brain. It's like it can tell the time of how long it took to speak a sound, have it come back, like how long that took, and then also it knows the speed of sound, and using both of those things together, it can get distance. So what we're going to do is actually our robot needs to do this using code. Now I'm not going to get into all the details of how the code works today, but I just want you to understand what's going on is that we're using speed of sound, and we're using time, and those two things, our ultrasonic sensor is able to get distance. All right? Okay, so now that we know that, let's talk about how to wire this thing. All right, so let's start our ultrasonic sensor. Here we go. Ultrasonic sensor, and I want you to notice the 4 signals here. We got VCC, trig, echo, and GND. All right, and while I'm in this view, let's go ahead and I'm going to put my ultrasonic sensor on my breadboard, and just like the potentiometer, I want to make it so that each of these pins is on its own row. So I'm going to do something like this. There. Okay, each of its pin is on its own row. All right, let's go back here. All right, so now let's make our schematic. Okay, here's my ultrasonic sensor. Got 4 things, 4 pins, right? Okay, and they are VCC. They are, the next one is, just want to make sure here, trig. So I'll just put T. Echo is E. And then I have a GND. A GND. All right. So how do we wire these? Well, the easy ones are VCC and GND. That's our power and ground. So let's go ahead and make that connection. Okay. We have, this is our Uno. 5V, and also a GND. Okay, so the VCC is going to go here to 5V. GND is going to go here to GND. Okay. Now, trigger and echo, we need to find 2 pins that are available on our Uno. So let's give that a shot. All right, on my Uno, now yours may be a little bit different, but mine, pin 4 and pin 7 are currently available for me. So I'm going to use those. All right, so pin 4 and 7. So I'm going to use trigger for 4, and then echo for 7. Okay. My wiring diagram's a little bit messy because of the way that I have to, do these humps to cross over these lines. This hump here just means that this line here is not connected to this line here. All right. Okay, so now let's go ahead and try to make the connections. Oh, and I see the camera view is wrong. So this is a bigger view of the camera. Or sorry, a bigger view of the whiteboard. Okay. Now, let's see if we can make these connections, all right? All right, so let's first do the VCC and GND. So going back this way. All right. VCC, so I need a 5V. All right, so I think I have, all right, 5V. I don't have any more 5Vs on my Uno, but I do. This yellow wire right here is 5V. Okay, so what I can do is just go from there. And I'm kind of running out of colors, but I will do what I can here. Okay. Alright, I think I found another yellow, so I'm gonna... So this row right here is 5V, so I'm gonna stick it into there. And stick it into VCC, other side. Great. So there's that. And then my GND, I'm just gonna find somewhere on my breadboard that I have GND. Now, we've learned about using these ground and power rails. That's probably the best thing to do. So if you want to go ahead and do that, or you're doing that already, even better. But for now, just so we can keep going on this video without changing everything, I'm just gonna find a row that has GND already. So I think this gray, yeah, this gray wire is GND. So I'm gonna put this white one, the same row as that gray wire, and then go to my GND. Cool. There we go. And then now we just do the pin 4 and 7. Take a blue wire. 4 is here. 4 is there. And that's going to go to 4 is going to trig. There we go. And then 7 Alright, this goes to echo. Nice. I think I'm good here. Alright, so now let's go ahead and go to our code and see if we can experiment with this. Okay, so here's my code from last time, and I'm gonna just put this here, plug this in here. Okay. And make sure you can see everything. Okay, so here's my code from last time. I'm going to go ahead and copy in a function here. So if you see my screen, I just copied it from somewhere, and I'm going to paste now. You see all this? It's called int ultrasonic, okay? So this is some code that we don't need to understand all of it right now, okay? We're just gonna copy and paste it in there, and I'll make sure that it's here in the video comments or the video description section, okay? So you'll have the same code that you can copy and paste. So this is the ultrasonic function. We're gonna be using this. The thing we want to know is that you put in a trig pin. For us, it's 4, and an echo pin. For us, it's 7. All right, and then it will return. What's going to happen is it's going to return int, and it's going to be the distance. All right, so you just put in the trig pin, the echo pin, and then what comes back is going to be the distance. So let us figure this out. So the first thing we need to do is set up our pin modes, because nothing's going to work if we don't do that. So pin mode 4. Now 4 is the trig pin, so trig is going to be output, and then pin mode 7 is the echo pin, is going to be input. All right, now going back here, I want us to think about this here, this bat picture that we were talking about. Okay, so trig is this going out, and what is echo? It's what comes back. Okay, so the yellow is echo, the red is trig. That's why trig is output and echo is input, because it's coming back into the bat. All right, okay, that seems good, and we have our code copied here, ultrasonic. So what we can do here is, let's just read it out. Okay, so I'm going to say int distance, that's our variable. I'm going to say distance equals ultrasonic, which is the name of the function we just copied in, and then put in the 2 pins, 4 and 7. Right? 4 and 7. I want to make sure I did it right. Yeah, first one, it says trig pin, so that's the trigger, and then echo. Okay, so this should work, and then I want to read it out. I'm going to say I don't want potentiometer anymore. I want to just read out distance. Okay, so once I do this, I should be able to read out distance onto the serial monitor. Let's try this. Okay, it says 15. Interesting. You see I'm putting my hand way up to it. It's getting less, and then as I move my hand away, it gets bigger and bigger. Okay, let me I'm gonna zoom out here so that you can see this better. Okay, so I zoomed out the camera a little bit, and you can see if I go up close, it's small, and then go back. So you see it's kind of jumping around that number. It's not really smooth. So what you can do is get like a piece of paper or something, and you should get some more consistent numbers. So let me see. I wonder if this will work. Yeah, that works pretty well. See? Okay. So I'm going to turn it this way and see what happens here. So you can see the further I go out, These numbers keep getting bigger and bigger. I'm at 45. Now I think now the reflect, what's happening is that it's sending sound and then coming back, okay? And so the first thing I want you to do, so now it's detecting here, okay. See, it looks like, you see it says 29. It's probably bouncing off like the base of this camera right here is over there, and it's telling me it's 29 away. All right, so a couple things, challenges for you guys. Number one, wire up and code ultrasonic sensor, okay, to display distance to serial monitor. So basically what we just did here in the video, I would like you to do that. All right, that's the first step. Number two is I want you to determine unit of distance. What do I mean by that? Okay, when you're looking at the measurements, right, it has some numbers that are coming out, right? So my question is, when you see those numbers, I'll just go back here so I can show you. Okay, you see it says 29 right here, and now it says 7, 6. Okay, what's the unit when you see 7 or 6? Is my hand right now 7 inches away, 7 miles away, 7 feet away? Like what is it? Okay, so determine the unit of the distance. All right, you might need to think about how you're going to do that, okay? But that's part of the challenge. Think about determine the unit of the distance. I want you to determine the maximum sensing distance of the ultrasonic sensor. So there's a maximum there's a maximum distance that it can sense. So basically, if you get some object super far away, it can't even detect it. Okay, so I want you to see, what is that maximum distance? Is it a million, 10, 39? Okay, I want you to figure that out. And then number 4 is program the box to open when you get close, and close if you move away. All right, so basically, if you go up to the sensor, I want the box open. If you walk away from the sensor, the box should close. All right, so there you go. Should be fun. I look forward to seeing how things go. All right, we're in the home stretch here, so have fun, and I will talk to you guys later.